Successful Low Carbon Transition for Heavy Industry webinar. That's our project 3006 with the presenter, Associate Professor Emma Aisbett, who's the project leader for that project. My name is Jenny Selway. I'm the HILT CRC CEO. I was going to do a bit of an overview on HILT, but I think I'll skip that since we're 8 minutes late. But I would like to pay my respects to the traditional owners of the land, and I'm dialing in from the lands of the Wurundjeri people of the Kulin Nation today here in Melbourne, but pass those acknowledgements on to the traditional owners of the lands from wherever we may speak. So as well as Emma Aisbett today, we've also got Associate Professor Fiona Beck, who is our Program 3 leader. We have 3 research programs at HILT CRC, all focused on decarbonisation of heavy industry, iron ore, steel, alumina and cement. And one of those programs is called Facilitating Transformation, which looks at policy, regulatory and market factors to support green metals production in Australia. So given we are late, I might pass directly over to Emma, and then Fiona will join us at the end of the session for Q&A. Thank you, Emma.
Thanks so much, Jenny, and thank you everyone for bearing with us. It was my fault, I'll own it. I started the meeting too early and then we stopped it, and that was apparently an irreversible mistake. So are you seeing my slide now, my front slide? Yeah, and it's in the appropriate sort of view frame?
Yes, that looks great. Thanks, Emma.
Excellent. Thank you so much. So I've decided today actually to sort of zoom in on one specific issue, but I really hope it will be an issue that you agree is of great importance. And I hope in zooming in on this one issue, you'll also see the sort of value that the research that we're doing more broadly in Project 3.06 may be able to bring to HILT partners and to the broader Australian stakeholder community. So that issue is chain of custody. It's something that I've had to take a crash course on myself, so I thought I would share insights from that. So chain of custody, you're probably familiar with the term. I'm referring to the ISO. ISO have a standard on chain of custody terminology from 2020. So it's really about how information is passed along supply chains from sort of initial producers or extraction all the way through to final customer. And there are different models for how you can sort of transfer that information. The reason that the ISO came out with this standard in 2020 is because these chain of custody questions are increasingly important across a whole range of products and very much these days related to a lot of sort of environment and sustainability and health type pieces of information attached to the supply chain. So the ISO standard sort of identifies 5 broad types of model: identity preserved, segregated, controlled blending, mass balance, book and claim. Don't worry about trying to understand those too much for now. I'll talk about them in more detail later. But I would like to point out that although the sort of 5 broad categories, the mass balance category in particular sort of can spread out in a million different ways, and the devil is very much in the detail. Oh. All right, so why am I talking about such a seemingly esoteric technical point to this audience today? Actually, in my opinion, chain of custody models are probably the single most important issue that I could talk to Australian stakeholders about today. Why is it important? Because the devil in that detail means that if we choose the wrong chain of custody models, we won't get the industry decarbonisation that we need. So the climate impact of heavy industry around the world in coming decades depends on getting these right. And very much for Australia, our comparative advantage in green heavy industry really depends on getting these chain of custody rules right. And I'll explain why that is as we go along. Why is it important to talk to you about this now? Because there are some very powerful interests, particularly, I'll name and shame, the Japanese steel industry, who are making a concerted global effort to impact the norms around chain of custody. So sort of working on, let's try and kind of make changes to this seemingly esoteric technical detail that can unravel the whole system. And they're doing that at a time when a number of key greenhouse gas accounting and climate standards are being revised, including Science-Based Targets Initiative, the GHG Protocol, ISO, and World Steel Association guidelines. And indeed, most of the action is coming through World Steel itself. And I must apologise to our cement and aluminium partners, but I suspect exactly the same issues are going to be going on in those for those products and sectors as well. And this matters because the norms in this regime, and these are key elements of this international regime, really determine, what happens with the First Movers Coalition, what happens with Industrial Decarbonisation Initiative. A lot of these things have their supports, as do the supports of many governments, tied to these international norms. Similarly, the Japanese at the same time are making a real push at the WTO to pressure member governments to ensure that they adhere to international standards for their own embedded emissions accounting framework. So sort of putting pressure on things like the Australian government's GEO scheme to adhere to international standards. So they're simultaneously trying to influence those international standards and force everyone to stick to them. So this is a really, really timely issue. So how am I going to talk to you about chain of custody models? A little bit of shameless self-promotion. I can see my wonderful co-author, Sola Burkett-Vieva, is on the call today. We have a working paper, and the QR code, which looks a bit blurry, may or may not work, is there if you're interested, on designing high-performance international regime for embedded emissions accounting. It's sort of in international organisation circles kind of known as the pyramid paper because it went a bit viral after my WTO Trade and Environment Week presentation last year. What the pyramid really does is to help us, just give us a structure and analytical framework, a very simple one in this case, for thinking about all the many different sort of complexities in the design of the embedded emissions accounting regime. So starting with very general objectives down to overarching principles, some more detailed supporting principles, structure, rules, and then really down in the weeds for product-specific boundaries and methodologies. So it's just a way of organising our thinking about these things. So the paper talks about and makes recommendations, design recommendations for all different parts of this design pyramid and covers a whole lot of stuff. But today I'm going to focus on the things that are most relevant to the conversation about chain of custody models. And that's mainly the top 3 layers of that pyramid. So the general objectives of the regime, the ones that we have focused on are efficiency and effectiveness. Of course, there are many different legitimate governance objectives about participation and so on and so forth. Our paper and the conversation today are really going to focus on the efficiency and effectiveness of that regime. What sort of overarching principles support an efficient and effective regime for embedded emissions accounting? Relevance, least restrictive means, and non-discrimination. These are principles I'm not going to talk about in any great detail today because last year I talked to the same audience, or hopefully overlapping elements of this audience, about exactly these principles. We derived these principles from a systematic review of both the literature and the carbon accounting practice, including GHG protocol. So relevance really just means the information presented is relevant about the embedded emissions, is relevant to the people who are trying to use that information. Least restrictive means is a trade policy principle. It means that you're achieving your objective in the least trade restrictive means possible. Non-discrimination, importantly, our definition of non-discrimination says that the framework or the regime should not confer advantage to one product over another where they're like products and where the definition of like actually depends on the actual embedded emissions of that product. And that's sort of key. To anyone familiar with emissions accounting, accuracy, conservativeness, monotonicity should be fairly clear. Monotonicity, perhaps being less obvious to some people, means that you shouldn't be allowed to look like you're lowering the embedded emissions of your product while actually increasing global emissions somehow. Subsidiarity says that the information should be generated at the location where the emissions are happening, essentially. Transparency, obvious. Comparability, we're interested here in comparability between products, less so in comparability over time. Flexibility in this setting means that the regime, or in fact, in particular, embedded emissions accounting framework, so the GEO scheme, should be designed in a way to be useful for as many different purposes of different regime participants as possible. So you could think about the fact that the Australian GEO scheme has been designed quite flexibly. It could be used to support certification of the emissions and just provide that sort of information. It is being used to identify qualification for future made in Australia type subsidies for hydrogen, for example, so far. It may well form the basis if Australia ever is able to have a carbon border adjustment for those calculations. So that's the meaning of flexibility in this context. Interoperability, of course, means that different embedded emissions accounting frameworks should be able to pass useful information to each other. Of course, hugely important with regard to international trade, because we know supply chains cross national borders. There's a whole bunch of things we talk about in the paper under framework structure. I'm not going to focus on any of them particularly today, but one of the things we discuss under framework rules are the emissions allocation rules among products and co-products. And that is definitely relevant today and relevant to the chain of custody conversation. Now, you might be asking, I'm talking about efficiency and effectiveness. You would be fair to ask efficient and effective at doing what? Of course, these things need to be defined relative to an objective for the regulatory regime that we're talking about. So in the paper, we look at the sort of preambles and the text in a whole bunch of different embedded emissions accounting frameworks. And from that, we distill that it seems the purpose of this regime is really to support decision-making based on product embedded emissions information. And that might sound sort of self-evident and tautological, but it's not necessarily self-evident, and it's very important. If you don't agree that that's the objective of this regime, then nothing that I say will necessarily make sense in the rest of this presentation. So if you're an economist and into market failure type language, really what we're saying here is that information asymmetry between supply chain participants and governments, customers, investors, that is the key market failure that this regime is trying to address and remove. And solving that market failure allows the different actors to address other market failures. So if I'm, if I'm a government or a customer who cares about the climate externality, I can use that information to take actions on that basis. Similarly, if I'm a government who's trying to help to get genuinely innovative new clean industries off the ground, I can use that information. That is a slightly different, it's not sort of self-evident that that is the objective. And our friends there at the Superpower Institute, for example, some of the recommendations that their recent reports have been making seem to suggest that their understanding of what this regime is trying to do is trying to essentially be a proxy for our incomplete carbon markets, and to try to expand the number of economic actors who are explicitly or implicitly facing some form of carbon price. Obviously, that's not the position that I take with regard to this particular regime. I think there are different policy levers and different information tools that can be used to achieve that objective. So just making clear that, in my view, this is what the purpose of this regime is, and this is what it should stay at, because there are other regimes, other policy tools to achieve other objectives. All right. I apologise, I'm trying to move quickly since we lost some time at the start. In order to explain the chain of custody models, I'm going to make use of some wonderful diagrams that were in a recent paper by HILT CRC et al. And they are actually looking not sort of with all the same comments that I'm looking at, but they are looking at this issue of chain of custody and carbon footprinting, and also point out the incompatibility of the approaches that involve separation of physical and accounted products. So sort of some mass balance models and book and claim models, the incompatibility of those approaches with standard life cycle analysis emissions allocation conventions. Right. So now I just wanted to take you through a quick overview of my take of how each of these different chain of custody models that the ISO talks about align with our recommendations for sort of how to design a high-performance global embedded emissions accounting regime. So, for example, starting with the identity preserved model, which is really just a kind of illustrative example in the case of something like heavy industry. It's really something that is best suited maybe to your organic eggs. It's highly consistent with most of our design recommendations. It's very effective at supporting decision making, and sort of have all sorts of wonderful things about accuracy and so on. But of course, this high level of traceability, exact traceability and separation does mean that you might be a little less efficient and a little more restrictive than ideal. So this is just sort of justifying. And in particular, in the case of heavy industry, if you're thinking of getting raw materials from different places and combining them at one very big steelworks or concrete plant, you may understandably want to be able to blend those different inputs. And of course, on these diagrams, green means green input, grey means a grey or conventional input, and green and grey sort of reflect how the, on the right-hand side of the little diagram, reflect how the resultant output or product looks sort of when it's certified. What does it look like to the customer at the other end? And the two different blues, the dark blue is one physical plant that has three potentially totally separable production lines with three different inputs, and the lighter blue is just an illustrative, simple example, just a separate establishment somewhere else that only has one production line. Okay, and so as you can see here, if you're thinking about something like heavy industry, keeping those input lines completely separate might have a bit of an efficiency cost if you want to get your economies of scale in production. So the next sort of least conservative, if you like, chain of custody model allows you to mix inputs that have essentially the same characteristics. So if you had, for example, green hydrogen going in from two different sources going into that production chain, you would be allowed to mix them in a segregated model. And the idea here is the supply chains are kept separate. for the conventional and the green product. So this, is a little less restrictive than the first model. Though you do lose some information. So maybe it's not something as simple as green hydrogen that maybe I don't necessarily care, or maybe I do care whether if this was clean hydrogen. In either case, maybe I do care whether it was actually made with SMR plus carbon capture, or maybe it was made with renewable energy. So you do in this model potentially lose a little bit of information, but you do kind of gain a bit, and generally unproblematic from the perspective of someone wanting to design a high performance regime. Controlled blending starts to look like something that you might expect to see, particularly for big players or players that already have existing plant where they've been working with sort of conventional processes already. So controlled blending allows you, to take your different fuels. Maybe I don't know, this is unrealistic, but you throw some coal in along with your green hydrogen, or you throw some natural gas in along with your green hydrogen to do direct reduced iron, for example. So as long as in the controlled blending, it's fine as long as you're not mixing information about stuff from physically different process lines or supply chains. You're allowed to sort of blend, but the resultant product, you're not allowed to claim, you're not allowed to split up and say, oh, we made some really clean product and we made some dirty product. Controlled blending says you have to, if those processes are physically mixed, the resulting output is kind of an average of those in terms of its emissions credentials. Once again, this is pretty unproblematic from the regime's perspective, although might sound sort of antagonistic to producers who are thinking, but wait, I've got pretty good green credentials there. I must be able to sell some green certified product as a result of this. It might confer also, this approach might confer some advantage if you think about sort of this non-discrimination comparative advantage thing, might confer some advantage to sort of existing incumbent industry, particularly if you think if the certification scheme was such that up to a certain amount of greenness you could still call it green, then you could have some advantage of sort of blending blending in the dirty material into the clean stream to increase the amount of clean material you're making up to exactly that threshold and still be able to call it clean. But overall, this one again is unproblematic from a regime perspective. All right, so then we get to mass balance. And the thing about mass balance is it comes in many different varieties, because mass balance just says you have some rule for that allocation. So the mass balance approach lets you actually kind of combine information about product that never actually intersected physically, that came from entirely different process lines, was potentially made in different countries. So the most conservative version of the mass balance looks actually pretty similar to the controlled blending one, except that you're allowed to combine things from physically sort of non-interacting supply chains. So the problem with that, of course, the information no longer reflecting the physical supply chain might mean that you're not actually providing information that's relevant to people, to customers, to governments who actually wanted to be able to target the product itself and that actual supply chain. They might not be interested in what you're doing on average as a firm with multiple sites, for example. So you might well be violating the sort of effectiveness at achieving the regime objective, and particularly on that relevance principle. This also, even more so, is likely to confer advantage to producers who have multiple plants and once again can launder some of their high emissions product in. In terms of emissions allocation norms in embedded emissions accounting frameworks in life cycle assessment, there's a hierarchy is usually sort of agreed, and that the first hierarchy is that you should allocate emissions by separating the processes as far as possible and just sticking as closely as possible to that physical allocation method. So that's what you got with those sort of segregation and the first approach. If you can't do that, the next, the sort of hierarchy varies, but among the legitimate options are a mass balance averaging. Alternative options are, for example, economic allocation of different emissions to different byproducts and products from a process. So, so the emissions allocation rule is sort of yellow for this one because we haven't used like the first best of keeping everything separated, but this sort of averaging based on the mass of product is one of the legitimate options in life cycle or most embedded emissions accounting frameworks in existence today. So you're not first best, but you're not violating anything egregiously. So Holtz et al. Also talk about something which they call a credit method for the mass balance. And in this way, what you're seeing is even further sort of separation between what's going on in the physical supply chains and in what happens with the accounting products at the end. And the big difference here is, of course, you are now violating any form of accepted emissions allocation rule, because you're just deciding you're going to sort of dump all of the emissions onto one product and then make as much certified clean product as you can. So this starts to look like a little bit of accounting wizardry. So you're getting sort of some more accounting complexity. You're certainly really challenging the transparency principle. You're definitely challenging the effectiveness of the regime and its relevance to what the regime, in my view, is set up to do. And you are, as I said, violating emissions allocation rules, because there is no accepted emissions allocation rule in any of these existing embedded emissions accounting frameworks or life cycle analysis rules that says you can take this sort of approach. The last one sort of covered in the Holtz et al. Paper and the last category in the ISO is a book and claim model. And so here it's kind of similar to the previous mass balance model, except you can actually just go and buy essentially offsets. You can go to market and buy offsets to make your product look green. So even if you have only one plant making conventional dirty product, you can just buy yourself some offsets and get it certified as green. And that, of course, violates pretty much everything about what this regime of embedded emissions accounting has been designed to do. So it's not, it has slightly different sort of competitiveness for genuine green product issues to the book and claim, to the mass balance with credit model. So if you're allowed to buy offsets, of course, essentially what you'll do is run down the green premia to be equal to the price of whatever offsets you would need. So you're going to really shrink that green premia, because everyone on this call knows that genuinely decarbonising heavy industry is a lot more expensive per CO2 molecule currently than some of the alternative ways to generate offsets. On the other hand, relative to that mass balance credit model, if I go back to the mass balance credit model, the problem with the mass balance credit model was it had conferred huge advantage to existing incumbents who are able to kind of launder a fair bit of emissions, high emissions products. So maybe in order to kind of create green product, right? Whereas no one who's a small player, genuinely green player, can take advantage of that laundering option. The issue here is not so much between different types of players, except the issue with the book and claim model is that you've just really shrunk that green premium. And so green production will really struggle to get the financing that it needs, especially at the start when it's more expensive. But wait, there's more. The World Steel Association is suggesting another version of a mass balance model. They're calling it a mass balance model. Essentially, though, what it really is a book and claim model, only you're not allowed necessarily to go to the market and buy offsets, but you can use within firm insets. And in particular, embedded emissions accounting, one of the things about the regime is it's actually about how many emissions were associated with that supply chain. It's not a relative statement. It's not about how much less polluting that supply chain is than it used to be. And that's a wonderful thing, because we know that baselines, we know that additionality, we know all these sorts of things are so highly contested. They're so not trusted by many stakeholders that they can really undermine the trust and perceived integrity of a regime. The World Steel Association proposal is to allow exactly this sort of stuff within a company, but the company can still create itself those inset credits by determining what its baseline emissions would have been and claiming that in their Puerto Rican plant they would have been this much more emitting, but they've now done X and it's slightly less, and therefore I can sell green steel in Australia. So that's the essence of the World Steel Association proposal. You may not be surprised to hear that's worst case scenario for Australian industry. It has all the problems of conferring advantage, comparative advantage, or sort of unfair advantage actually to incumbent industry, and still having a lot of the problems in terms of the integrity of the accounting associated with all those things about baselines and additionality. This is the proposal that's being pushed. This is a big problem for Australian industry if we want to have any hope of growing clean, green, competitive industries. So Australia's natural comparative advantage gives us a chance, to really grow green export industries to replace our naturally declining fossil fuel industries. But that natural comparative advantage can easily be wiped out by gaming by vested interests to generate themselves policy-induced comparative advantage. Therefore, Team Australia need to pay attention. We need to step up and we need to get involved in these international fora and make sure that in the end, what we have is a high integrity, high performance international embedded emissions accounting regime. So thank you very much. And I look forward to discussion.
Thank you very much, Emma. My name is Fiona Beck, and I will be moderating the question and answer session. So please do. I can't look at you all on the screen at once, so please do raise your electronic hand or put your questions in the chat. So we already have one in the chat from Matthew Rumsa. So in a scenario where Australia produces DRI using natural gas as an intermediate step, how should future policy consider this onboarding of domestic Scope 1 emissions within carbon budgets, and where we also see a greater reduction in downstream Scope 3 emissions? So I think this is a really big, important question. How do we deal with growing domestic emissions as we offset our very, very significant and consequential or downstream Scope 3 emissions in Australia? You're on mute, Emma. Just, yeah.
Thank you. It's a good question, and it's a good, almost a Dorothy Dixer for me to say, not my problem. And I mean that in the nicest possible way. The purpose of this element of the regime, this regime that I'm talking about, is to understand product embedded emissions. And this is a related but a separate regime to national accounts. So the national accounts are really about understanding and allocating and promising emissions that happen within a certain jurisdiction. But and that can be from a whole lot of different processes, but they're really sort of tied to physical place traditionally. Embedded emissions accounting is about following the emissions for a particular product as it moves potentially through multiple different jurisdictions. So that is a super important question, but it's not a question that I think the embedded emissions accounting regime is particularly designed to answer.
Thanks a lot, Emma. Just noting as well that, this is actually a question, that part of the question, understanding the different boundaries of accounting schemes, is one that sort of comes up again and again. So here, boundaries are around a product, not around a country. So please do get your questions in the chat. Emma, while we wait for some more questions, I'm going to ask you the really sort of devil's advocate question, which is, if you take a pure economic lens of this, the fact that you drive down the green premium to the cost of whatever carbon offset you're buying is just, collecting those low-hanging fruits, pouring money into the most efficient way to draw down 1 kilogram of carbon dioxide. Isn't that exactly what we want the world to be doing? And isn't that the basis of all sort of carbon credit type trading? So could you maybe talk a little bit to that?
Absolutely, and thanks for asking that.
Noting
Fiona.
that I don't necessarily at this. Yeah, but don't necessarily believe in the position I'm asking from there.
No, but it's a really important one because, we have Ross Garnaut pushing it, right? So whenever Ross Garnaut's pushing something, you need a bloody good argument to argue against it. So thank you for letting me elaborate again on that. It really comes down to what I mentioned earlier is that, yes, if that's all you're trying to achieve, if you're trying to use this regime to lower our cost of reducing the climate changing emissions right now, sure, go for it. Try and just get the costs down. However, as I argue, that's what carbon markets are for, as you say, and there's a whole range of different policy levers there. This information can be used to address different market failures, including those associated with sort of new industries, right? We know there's a whole lot of market failures that inhibit the growth of new industries. And so we really need to know that we're targeting products made by these actual innovative clean production methods. And what that can do also, if you don't care about new clean industry in its own right, and all you care about is the climate externality, bear in mind that in order to get to net zero, we need to decarbonize these industries. There aren't enough trees we can plant in the world. There aren't enough other offsets, especially once everyone's heading to net zero. So many offsets are, produced by reductions elsewhere. But when we're all hanging out at zero, no one's generating those offsets. We need to decarbonize those industries. So if you look at the emissions cumulative over the next 50 years, the approach of keeping this separate is actually what's needed to start scaling decarbonisation of heavy industry.
Great, thank you very much, Emma. We have another question from Ro Richardson, who says you've made a very good case that Australia's interest meets the case case for good CRC processes to be required, who is responsible for putting this case to the international fora making the decisions?
All of us. So I'm out there, Fiona's out there, as I know, advocating for a high performance regime. World Steel Association are a major player here. Industry people, you're major players in the World Steel Association. We supply so much of the raw materials that that the whole world's system relies on, and of course the Australian government through the many different fora, like their OECD engagements with the Green Steel program there, through IDDI, through First Movers Coalition, all Australian stakeholders I think should be singing from the same hymn book on this one.
Fantastic. So a call to action as well for everyone who has any type of stage they can speak from. Chris McMahon asks, or it's a statement with a question mark at the end, but I think if you ask it with the right intonation, it's a question. A mass balance approach can help create demand for green steel earlier and reward existing producers to invest in decarbonizing assets. So I think he's asking, is that the right way to think about it?
That's the World Steel jargon. And so the World Steel Association say, look, there's all this demand for green steel that we can't meet yet if you're really strict about it. So let's meet that demand by any means possible, essentially, by these sort of accounting tricks, for lack of a better word. But the thing is, that demand was being generated by things like the First Movers Coalition, by Industrial Decarbonisation Initiative. If you look at their documents, if you look at their websites, their objective is to actually stimulate demand, to encourage investment, to provide the big premium needed for genuinely decarbonised production processes. They're not actually out there to incentivize marginal emissions reductions on essentially conventional processes. So I think it's really disingenuous of the World Steel Association to say, there's all this demand, we need to meet it by doing these accounting tricks. That's not what the demand is actually for. And you will actually completely undermine things like the First Movers Coalition and IDDI if you engage in these accounting tricks.
Thanks for that. Please do get your questions in the chat. So while we're waiting for real green steel producers to decarbonize, do you think there's a role for some sort of initial laxer regulations around certification, maybe something like we're seeing with, for example, the RED II directive in the EU, where they're having lax temporal correlation requirements for renewable energy initially and then tightening them up later. Do you see something like that happening as a good way to actually allow this meeting of early demand, but then also driving true decarbonisation?
Look, one of the steel standards principles, the IEA principles as well, is about stability of international standards. So you don't want to be changing the standards themselves over time. So I would argue, net zero steel or essentially near zero steel should be genuinely near zero steel from now. And there are some pilot projects already doing that, right? So give them the backing that they need. Give the companies who are being ambitious, including some of our HILT partners, the certainty, given the market benefits that they need. There are many other types of policy approaches that can incentivize continual improvement. And in fact, something that I advocate is to support the Australian Guarantee of Origin Scheme approach, right? So there's internationally, there's all this, we need agreed standards. I generally say I don't think we do. I think what we need is interoperable, comparable, flexible embedded emissions accounting frameworks, so we can actually exchange trusted information on what the embedded emissions are in a particular piece of steel or concrete or aluminium. And so I do think that actually this focus on this binary standard of clean, not clean has somewhat backfired.
That's really interesting, Emma, and I totally agree with that approach, actually. Numbers, not colours or labels. Roy Richardson has another comment here. Surely it would be better to work with customers and demand for green steel to insist on rigorous COC models rather than to persuade producers to avoid shortcuts. So I would say that again kind of agrees with the approach of actually putting numbers to emissions embedded in products rather than labels. But maybe you can talk a little bit to that.
Yeah, and so thank you for that clarification again. We're exactly talking about, so these frameworks for the certification schemes and embedded emissions accounting more generally, they're usually multi-stakeholder, especially the most important ones. So there's the customers, there's the investors, there's the governments, and there's the producers all in there. And we do need the customers and the governments to push for these high integrity standards. And that was what was happening. So this has been a relatively recent push from essentially the Japanese steelmakers who know they don't have a comparative advantage in genuine clean steel, unlike Australia, to try to water down those internationally agreed norms and standards.
Excellent. I'm trying to take notes while also moderating is not not necessarily easy. So here's a question from Anthony Coles in China. He gives you a wave. Nice work on the COC conversation starter, Emma. Insetting is a relatively new model offering potential to redirect net zero ambition of China's steel industry into upstream decarbonisation investments in the Australian supply chain. Is there any substantive cross-border Australia-China work being done on establishing the EEA frameworks for this, for a pilot or CCER ACU? I'm not across all of those acronyms, actually. I don't know if you are. Maybe Anthony can give us some definitions.
So I actually violently disagree with you, Anthony, on this particular point, right? So I think you're advocating, for that World Steel Association approach, and it means, or even a book and claim model, which means you can get your offsets or insets from wherever. If China uses green iron from Australia and then, processes that in their downstream steelmaking plants in China, using one of the more rigorous COC approaches, that shows up as green, right? So the rigorous approaches incentivize exactly what we want to happen. My whole point is these less rigorous approaches offer alternative pathways for Chinese or Japanese steelmakers to look like they're producing something equally green without having to use clean iron from Australia. Oh, and on the Australia-China collaboration, I know there's various projects, including, Frank Yotso and Yorik Gossen's work, and several others supported by the Australia-China Foundation. And yes, I've even thrown my hat in the ring to work on that through the foundation this year as well. So we'll see.
Fantastic, thank you. So another comment from Matthew Rumsa. Do you think the COC models for embedded emissions in kilogram of carbon dioxide equivalent could be expanded in the future to consider broader environmental impacts? For example, from life cycle analysis like acidification.
Yeah, and so to be clear, the chain of custody stuff is one particular technical detail in how you do what I refer to as embedded emissions accounting. And exactly that paper that's got the QR code in the presentation, we talk about a whole lot of different things, and one of them is the information layers. And certainly there is many certification schemes that have other information layers, and these are really important from broader sustainability perspectives. So yes, a lot of certification schemes have that. I think it's a good thing. And in the paper, we talk about issues around interoperability related to that.
Great. And then I think might be our last question. So how do you recommend dealing with the buy co-products on a mass basis or economic basis? If the byproduct is high volume but low value material, the mass balance basis may make it uneconomic.
Yeah, so different embedded emissions accounting frameworks have different hierarchies. As I said, first best is always to keep things separate if you can, but of course you can't always keep it separate. And what the appropriate hierarchy is one of the most challenging things from the perspective of interoperability, particularly if you're thinking of trying to design these frameworks so that they're consistent for a broad range of products. If you think about the Australian Geo Scheme expanding beyond hydrogen and its direct derivatives into clean metals and so on, you really want consistent rules. Otherwise, you're going to end up with some opportunity for gaming. Yet it is one of the most challenging areas where for some products, it really makes sense to use mass. For some products, it really makes sense to use economics. And it is another thing that we discuss in that paper. But no easy answer.
Fantastic. Thank you so much, Emma. If I could perhaps suggest that if it's easy, can you throw up that QR code again so that people that didn't get it in the beginning?
I can throw the link in the chat maybe. Would that be helpful?
Yeah.
Thank you.
Yeah, that would be fantastic. So I'm going to have to draw this to the close now. And Anthony Coles has a final comment in the chat that I'll let everyone read. But it starts with the word agree. So maybe you don't disagree so violently.
I was surprised if Anthony and I didn't agree. Yeah. Excellent.
Thank you very much thank you, Emma, for sharing your expertise with us. As very excited and interested to see what comes out of the RP3.006 certification and projects going forward. Thank you to everyone else for joining us for this webinar. Apologies again for the minor technical issues, but thanks to the HILT team for resolving those so quickly. This always wonderful to have interaction in these webinars as well. So thank you to those who were active in the chat. But yes, thanks again, Emma. Great to have you.
Thanks so much, Fiona and HILT, and wonderful audience. Always a pleasure.